Have you ever been stuck with a single data model that has to do everything? You know the one, it needs to be lightning fast for writing new data, but it also has to be flexible enough for these complex, slow-running reports. It's a classic struggle, right? Where optimizing for one thing almost always seems to break the other. Well, today we're going to break down a pattern that is designed to solve that exact problem.
Okay, so here's what we're diving into. First, we'll talk about the core problem, why that one model causes so many headaches. Then, we'll define our solution, CQRS. We'll see how it actually works with a real example, introduce its powerful sidekick, event sourcing, and then, most importantly, we'll get real about when you should and shouldn't use it.
All right, let's set the stage. In modern software, especially with microservices, the whole goal is to build our systems out of these small, independent parts. But that dream often smashes right up against this very old-school idea, the single, giant database that everything has to share. And that, right there, creates a huge conflict we need to solve.
So on one side, you've got the traditional model. It's one database, one data model for both reads and writes. And yeah, it's simple to start, but it creates this really tight coupling. If one service needs to change the database schema, it could break everything else. But on the other side, you have the microservice ideal, totally independent services that don't share data. This is how you avoid bottlenecks and single points of failure. The big question is, how do you bridge that gap, especially for something complicated like reporting?
So how do we solve this data dilemma? Well, let's introduce a design pattern with, I'll admit, a bit of a mouthful for a name, but the concept behind it is beautifully simple. It's called Command Query Responsibility Segregation, or for short, CQRS.
At its absolute core, CQRS is about one simple, powerful idea. The model you use to update information can, and probably should, be different from the model you use to read it. Instead of trying to force one model to do two very different jobs, we're going to create specialized models for each task.
So what this means in practice is you basically create two separate highways for your data. You've got the command path. This is for anything that changes the state of your system. Its model is built for one thing and one thing only, writing data safely and consistently. And then you've got the query path. This one is purely for reading data. Its model is completely separate and can be optimized specifically for super fast reads, complex reports, and data aggregation.
Okay, that all sounds great in theory, but what does it actually look like? How does this separation really work in a real-world scenario? Let's walk through a practical example to make this crystal clear.
So here it is, the classic problem we've got to solve. Your reporting service needs to create these really complex views of data, but that data lives inside another service. Now, if you're following microservice principles, it is a huge no-no to let that reporting service just connect directly to the other service's database. That would create that tight coupling we're trying so hard to avoid. So, what do you do?
Okay, let's imagine a company. We'll just call it Shipping Incorporated. It's got two key services. First up is shipment management. This is the right side of the business. It's constantly busy processing updates like package picked up or package arrived at the warehouse. The second service is shipment tracking, and this is the read side. It's the reporting service customers use to see where their package is right now.
And this just brilliantly shows the solution. The shipment management service gets a command and does its job. But, and here's the magic, instead of just updating its own database, it also publishes an event, a simple, unchangeable fact stating what just happened. That event gets sent to a message broker. Meanwhile, the shipment tracking service is just listening. It picks up that event and uses it to build its own, completely separate database, one that's perfectly designed for fast customer queries. And just like that, the services are totally decoupled.
Okay, so you might be asking yourself, wait a minute, what exactly are these events that we're publishing? And that question, that leads us directly to a related and incredibly powerful pattern that very often goes hand in hand with CQRS. It's called event sourcing.
Now, what is so fascinating here is the fundamental shift in thinking. A traditional model just stores the current answer. The package is in Denver. Where was it before? Who knows? That data is gone. It got overwritten. Event sourcing, on the other hand, doesn't store the current state at all. Instead, it stores a complete, unchangeable log of everything that ever happened. We don't just know the package is in Denver. We know it left San Francisco and then it arrived in Denver. The history itself becomes the source of truth.
This quote just perfectly captures the philosophy. The log of events, the facts, that's the permanent, rock-solid record. The current state of anything, whether it's a package's location or your bank account balance, it's just a temporary calculation based on that log of facts. We can rebuild that state at any time for any point in history just by replaying the events. It's incredibly powerful.
All right, this all sounds incredibly powerful, doesn't it? But let's be honest, it also sounds a lot more complex than just having a simple database. And that brings us to the most important practical question of all. When should you actually reach for this pattern?
This is such a critical warning from architects who work with this stuff every day. Adding CQRS and event sourcing brings new moving parts into your system, a new way of thinking. It's not a silver bullet. It is a specialized tool that adds complexity, so you should only use it when the problem really truly calls for it, not as the default for every single service you build.
So the real takeaway is you use this when the problem justifies the complexity. It's a perfect fit when your read and write needs are worlds apart, like, say, millions of fast reads but only a few thousand writes an hour. It is fantastic for complex reporting that needs to pull together data from all over your system. And if you absolutely positively need a perfect unchangeable audit trail of every single action, then the combination with event sourcing is just unbeatable.
And that's really the key thing to remember here. Don't think of CQRS as a blueprint for your entire system. Think of it as a specialized, high-powered tool in your architectural toolbox. You pull it out for those specific, really challenging parts of your system where the benefits of separating things out massively outweigh the cost of implementing it.
So in the end, CQRS isn't about choosing one tool for everything. It's about choosing the right tool for each job. The next time you're facing that conflict between fast writes and complex reads, maybe the answer isn't a better database, but asking a better question: should they even be using the same model to begin with? If this explainer helped you see your data a little differently, please do like, share, and subscribe for more deep dives. Thanks so much for tuning in.